Hey there, my name is Alfonso and I'm a developer advocate at the Cisco DevNet organization. I'm very happy to be sharing with you one more video from the Hack the RADKit series. And today we're going to wrap up our project of RADKit to Grafana dashboard. Today we're going to have a look at how to actually craft our very own dashboards in Grafana with the information that we're getting from RADKit using our API endpoints and our InfluxDB database. We will also have a look at how to trigger a cron job for scheduling this data collection. And well, if you haven't seen the other two videos from this series, I'm going to leave the links here in the description of this one. So without further ado, let's get started. Our API endpoints are ready. We can get real-time information from our networks and also time series-based information. What we want to do next is to actually see that information, render it in meaningful dashboards with all sorts of charts and graphs. For that, we are going to be setting up Grafana to show that information, pull it on demand, and show time series evolution, all that stuff. So I am here in my Grafana container. And what I will do next is to set up a series of connections to enable the dashboards that we want to have. Just bear in mind that all those instructions are here in the repositories wiki, but we are going to be following these steps together so you can see how it is done. So let me log in to my Grafana container. I will escape the password update. And then here on the left side, I will go to data sources. I want to add a new data source. For that, I will use the Infinity plugin. This is a plugin recommended by Grafana themselves. It comprises an interesting list of protocols which allow us to communicate with different data sources. In our case, we're going to be using it for the REST API and JSON features. I will just rename it here very quickly. We can do something like, I don't know, RADKit Fast API. Good. And I will set up a series of parameters here. So I can go here to authentication, no authentication. On the URL part, I will set up the URL of my Fast API container, which I have here from the documentation. Perfect. Then I will go to network and do skip TLS verify. And that's it. Let me go to save and test. And that's it. Green is good, health check successful. So now I want to set up a different data source. So I will go back here and click on add new data source. The one that I want is InfluxDB. So you can look here for Influx. It comes installed by default. And I will set up my information. So I will call this one RADKit/InfluxDB. The query language that I want to use is Flux. I want to use Flux because it's a more flexible, more comprehensive SQL-like language for doing the query of my InfluxDB database. So now here I will specify the URL, which is the one of my InfluxDB container. Perfect. Then for all the other parameters here, I will set up I will just go here directly to organization. So in organization, I will provide the information from my Docker Compose, which is organization RADKit to Grafana, token RADKit to Grafana, and my default bucket is going to be here, my RADKit bucket. So let's save and test, and voila, 3 buckets found. We are now ready to proceed. What we need to do next is to create our very first dashboard. A dashboard is a single pane of glass where all our different visualizations will be located at. So to create that, we need to go to the top right corner of the page, click here and go to New Dashboard. And then here, what I would like to do is to have on the very top a pick list where I can choose all the different devices within my RADKit service. inventory, so that whenever I change the device selected, all the different visualizations within this dashboard will change accordingly. So I can see information about the specific device at every single moment. For that, we are going to be using called variables. We can set them up by going here to settings, and then we go here to variables and add variable. Here we can specify which kind of variable we want. In this case, we want it to be variable type query. Then I will provide here a name. Let's say the name is going to be device, for example. Well, devices. Label, description, all of these are optional. And then here I select my data source. You remember that I created my RADKit Fast API data source. Then down below, what I want here to use is query type infinity. And then here we're going to be selecting a series of parameters. The type should be JSON. The method is going to be get, and then here in URL is where I provide my REST API endpoint. You remember that we have the endpoint devices, which gives us a list of the device names of all the devices within the RADKit inventory. So this is what I will set up here, and then we can scroll down. Here, I will just remove this one of allow custom values. I just want the user to be able to select what is there and nothing else. I will go here to run query, and that's it. We have our two devices in place. That means that everything is working just fine. So I will save dashboard, save, and then if I go back to the dashboard, you can see here that I have this list of populated values. Device 1, device 2. Let's create our very first visualization. What I want to have now is a table which lists some very specific parameters of all the different interfaces within my device of choice. So I will go here, add visualization. I will select my RADKit Fast API data source, and then I will go here to this corner visualization and select table type, because what I want to have is a table. Now here in the parameters of my data source, I will leave everything as it is because the endpoint that I'm going to use is the get one. It is JSON data. Everything is already set up. So now I will specify the endpoint from my REST API container, from my Fast API container, which is going to be this one. You remember that you created interfaces brief, and that my input argument would be the device of choice. So now here I am using this special notation because this one is pointing to the variable that I have here on top. So whenever I change this variable here, my query will change and it will reflect the outputs of this specific device. You can see here that I changed it already. It's already sending the request to my Fast API container, and voila, look at this. I already have the information, all these different parameters coming from my custom-made REST API endpoint. The format, the data messaging that we did in that Python file allows me to seamlessly render this information in this table in my Grafana. How cool is that? However, let's say that maybe I don't need all this information. I have here my interface is okay, my interface is status, IP address, all that stuff. Maybe I don't need all of that. Maybe I just want 4 specific parameters: name, IP address, protocol status, and interface status. So let's filter this a little bit and turn it into a more straightforward table. So let me collapse this option here. Actually, not. I'm going to go into this other option called parsing options and result fields. I will click here, add columns. And what I will do here, I will add here 4 columns. I will take the names of the columns that I want to save. I will rename them here, and this will be the only 4 columns left in my visualization. So I will start with name. You see here that we have the name column. So I will do here name, and then I will rename it to something more catchy like name, but with an emoji, right? Why not? Let's use emojis. Then IP address, which is this one here, IP underscore address, IP underscore address. I will rename it as IP address. Then I will use protocol status, which is this one here, protocol status. So I will type that here, protocol status, and put it here. Nice. And then finally, I will use interface status, which is this one here. So we'll do interface underscore status and select this here. And I will just click here, refresh, and you will see how this changes. Perfect. Now, it's a little bit strange still, because maybe I want to have the name column all the way to the left, and then all the different columns like in a specific order, right? So we can achieve that by going to transformations, add a transformation, and on the search for transformation type, what I want is organize fields by name. So you can just type here organize, it will pop up immediately. I will get it here, and then I can just rearrange them at will. So let's say that I want name first, then I want IP address next, then I want interface status and protocol status. That's it. Voila. It's all good. It's set and done. And then finally, these like up and down values, they're a little bit strange, right? They're like a little bit boring. Maybe I want to have something more meaningful, like a color code or even emojis. We can definitely do that using the Grafana custom functions that are available here on the right side. So let's go here all the way down to value mappings. We can click here on add value mapping, and we can add our transformations. So for example, let's say that for whenever we find an up, I want to have the check emoji. And whenever I have here the value down, let's say that I want to have the fire emoji. I click update, and voila, you can see here that all these values are being updated. And once again, well, everything is set and done. So if I go here to save dashboard, and then I click on back to dashboard, you can see that this is available on my dashboard. I can change the size, I can expand it all the way to the corners of my window. And then here, bear in mind that it is taking the device value in the REST API query from this pick list, meaning that if I change the device here, you can see here a slight hint of a progress bar. It will take some time, just a couple of seconds, but then it will come back with these updated values that actually correspond to my other device. You can see here that it changed a little bit. All these interfaces, all these values correspond to my other device. What we want to do next is to have here a new visualization, a graph, that shows the evolution in time of the traffic in all the interfaces within my device of choice. For doing that, we will use the records in our InfluxDB database and a new Grafana visualization. So let's go there. Let's go here on the top right and click on Add Visualization. Here on the right side, we want to select the visualization type time series. And then down below, we want to select the data source RADKit InfluxDB. And then here comes the interesting part, because we are going to be using a FluxDB language query. And it's very simple syntax. You have this query available there on the wiki, but I just want to explain you very briefly what is really going on here. So you have here the bucket where we will get information from. This is my RADKit bucket. And then we are saying, hey, from this device, which is devices that comes from our pick list here on top, I want you to get from the measurement interface traffic the value that you have in the field total rate, which is going to be our traffic rate in megabits per second. But also, please filter it based on this time range. Where does this time range come from? Well, this is provided by Grafana. I will show you later how to fine tune these timeframes, but it's just what you need to know. Like, hey, I'm filtering the information in these buckets. I'm getting all these records that correspond to these parameters in this specific time frame. And here I have my device selected, so I will just click on refresh. Okay, just let me change it a little bit here. Yes, there we go. Here is where you can change the information about the time frame. You can see here that we have last 5 minutes, 15, 30, all that stuff. We can also change here some other parameters. So here, the records that I have right now in my InfluxDB were done 3 hours ago, right? So I will have them here. And you can see that I have all this information of my interfaces. Let's make this a little bit more pretty, right? A little bit more readable. So to start with, I will go here on the right side and take my my legends, right? So we'll go here. Just give me 1 second. Yes, the placement of my legends, I want it to be on the right side. So now it's a little bit more readable. We have more room for my interfaces information. Now I want maybe to change this. I want it to be a little bit more distributed, a little bit more concise. So what I will do here is fill opacity. So we can have here this shade, different colors based on the interface name. Then I want to change the names of these legends because this is a little bit confusing. Like we have this dictionary-esque formats, and I only want the interface name so I can see that here it's way more readable. So for doing that, I will go here to transformations, add transformation, and just let me get this from my documentation. I will do here rename fields by regex. So we click on this one. The match is going to be this regex expression. Don't worry, it is all there on the wiki. And then here on replace, I'm going to get the first match. And you can see here that I have now all the names of our interfaces, nice and fine. It's all beautiful. It's all way more readable. The last thing that we want to change here is how this data is being reflected, because these numbers, they don't really mean anything to us right now. And the numbers that we get from the records in InfluxDB, they are in millibits per second. So we go here on standard options, unit, and we go here to MB. We select megabits per second, and that's it. This is how it is updated, and now we have this more accurate view, right? Let me save this dashboard. Let's go save it here again. Let's go back. And here we can expand it. We can change the size, all that stuff. It looks very, very nice. We can also filter based on what kind of interface we're having, right? For example, this interface, it had some traffic. If we hover on the different points, here we have that fine information. So as you can see here, before recording this, I triggered my API endpoint 1, 2, 3, 4 times. If I do it once again, you will find here a 5th record. So let us go back here. I will trigger it once again. Let's just wait a little bit. That's it. We have now fresh recordings. So let's go back to our browser. And if I refresh this, you can see the latest measurement that I took. And you can see here the timestamp, you can see here the value, and that is applies for all my different interfaces. Well, I have maybe this one, maybe this one. Yeah, for example, this one has a brand new record. So this is it. Now we have a consistent dashboard with real-time data and also with time series data from the devices within my RADKit inventory. What happens now if by any chance your Docker Compose services go down and your containers are destroyed? Well, actually, you are going to be losing all this work, all this effort that you did to customize your Grafana dashboard. Like, it will disappear on thin air. So a very good practice to keep all this efforts, all this customization, to save it for later use is to actually do a commit of this Grafana container. So you can later update your Docker Compose file, and whenever you spin up a new instance of these services, all your dashboards, all your data sources, everything is going to be there. So for doing that, let's go back to our terminal here, and let's use this command. Docker commit, then the name of your container, which in this case is Grafana, and then the new name and tag of this image, which in this case will be my custom Grafana RADKit demo. We do that, and we just created a new image based on this container. So then what you can do is to take this image with its tag, copy it, and put it here in your Docker Compose. You need to navigate all the way to your Grafana service, and then here on image, you can just use that image as it is. So next time you rebuild the service, it's going to be containing all those different customizations, dashboards, data sources. All your work will be there. What happens now to our dashboard that makes use of these time series data? As you saw before, I was manually triggering our REST API endpoint to get that information with a timestamp into our InfluxDB. However, of course, this is not sustainable. What I would like to have is an automated way to collect that data and to show it in my Grafana dashboard. So for that, we can actually use a cron job. A cron job that would be constantly calling this REST API endpoint and bringing that data into my InfluxDB, so it could be later shown in my Grafana dashboard. With this in mind, we incorporated an independent tool within this repository that helps us to set up exactly that, a cron job-based data collection for RADKit and InfluxDB. So what you see here is our wiki article explaining all the different steps, but let's just go through all of them together so you'll learn how this is done. So let's minimize this a little bit and go to our Visual Studio project. First of all, we need to set up the frequency with which this cron job is going to be triggered by our system. For that, we have in the folder RADKit to Grafana collection scheduler, the schedule.yaml file. You can see here that you can set up the frequency. This could be running on a specific date. It could be running on a periodic basis. In this case, we want it to run every single minute. The next thing that you need to set up is the script that will actually do that data collection. In my case, I have this collector.py file, and it will do two very specific things. First of all, it's going to be calling our devices endpoint to get the list of all the different devices onboarded in RADKit. Then with each of these devices, it's going to be calling the interfaces traffic endpoint so we can get that information sent to our InfluxDB. And here we're doing it using some Python multi-threading, just in case we have a plethora of devices, so that we can optimize this as much as possible. So now let's run this. Let's go to our terminal, and I will copy here a series of commands. This is, again, all documented on the wiki. We'll go to the folder. We are already in the folder. Sorry about that. Then we are going to be triggering this an sh file, a bash file that is included in the repository. I'm saying, hey, please create this cron job and create it and use the schedule.yaml file for specifying the frequency in which this script is going to be executed. So I will do that. It will create a Python container to execute the Python script. And then I need to allow it to create a cron job, and that's it. It is already created. And finally, after leaving it running for a couple of minutes, you will have a result like this. Like you can go here back to your dashboard, and you can see that in the last 15 minutes, we have all these different records. You can see it here. It's a plethora of records. And now we can actually see the evolution in time of the traffic within all the interfaces of my specific devices. If I change here to my other device, you can see here that I have also some other traffic. So this is just an example of a use case, but now it's your time to unleash your imagination and bring to life all the different use cases that will bring good intelligence, that will give good insights to your how you run your network operations. So this was it from my end. I hope that you enjoyed the video. I hope that you like the content. Please have a look at the repository. You can comment anything you want. You can fork it. You can report any issues. I will be more than happy to hear from you while you hack the RADKit.